Alright, so we have to determine whether the limit of 3x minus 5 over 5 minus x as x goes to 5 from the right approaches infinity or negative infinity. So to do this, since we know that x is approaching 5 from the right, we're going to substitute in a number that is really, really close to 5, but not quite, but that is slightly bigger since it's from the right. So 3 times 5.1 minus 5 over 5 minus 5.1. That is equal to, once you add or multiply that out, is equal to negative 103. So let's try that again, but get a slightly smaller number. So 3 times 5.01 minus 5 over 5 minus 5.01, and that will equal negative 1003. And then finally, let's try that one last time to make sure. 3 times 5.001 minus 5 over 5 minus 5.001, and that will equal negative 1003. And so we can see that as our numbers get continually closer to 5, that our numbers are getting smaller and smaller negatively, which means that our limit is approaching negative infinity. Okay. To find the vertical asymptotes of our function t over 4t squared minus 2t minus 12, let's first factor the bottom. So t over 4t squared minus 2t minus 12. So to factor this, let's carry our 4 over to the 12. So t over t squared minus 2t minus 48. And so that can be factored into t over t plus 6 and t minus 8. And so since we multiplied by 4 at the beginning, now we have to divide by 4. So 6 over 4 and 8 over 4. So we're going to end up with t over 4t plus 6 times t minus 2. And so to find the vertical asymptotes, you just set the bottom equal to 0. So 4t plus 6 equals 0. So you have to subtract 6 on both sides. 4t equals negative 6. And you have to divide both sides by 4. So t equals negative 6/4 or negative 3/2. And let's do our other equation now. T minus 2 equals 0. You just have to add 2 to both sides. So t equals 2. So we now know that the vertical asymptotes of this function are negative 3/2 and 2. Alright, so we have to determine whether our function 3 over x minus 2 squared approaches infinity or negative infinity as x goes towards 2. So we're going to use the same method that we did a couple of problems ago. So as our limit, as x goes towards 2 from the right, we're going to substitute in a number that's really, really close to 2, but not quite at 2. So 3 over 2.01 minus 2 squared, that will equal 30,000. And let's try that again. 3 over 2.001 minus 2 squared, and that will equal 3 million. So we know that at least as x is approaching 2 from the right, that it will go to infinity. But let's try from the left. So our limit as x goes towards 2 from the left, 3 over 1.99 minus 2 squared equals also 30,000. And let's try that again. 3 over 1.999 minus 2 squared will equal 3 million. So we can see that since it's the same from both sides, that x will be approaching positive infinity. Now we need to determine whether the graph of our function x plus 2 over x squared minus 4 has a vertical asymptote at x equals 2 or a removable discontinuity at x equals 2. So let's factor this first. So x plus 2 over x plus 2, x minus 2. And so we see that we can cross both of those out. And so if we did this, so to find your vertical asymptote, you would set it equal to 0, so x minus 2 equals 0. So you add 2 to both sides. X equals 2, so we see that there is a vertical asymptote at x equals 2. And for this one, it couldn't be a removable discontinuity because then we would set the one that we removed equal to 0. So x plus 2 equals 0. You subtract 2, and so x equals negative 2. And so since that's not positive, we know that it's a vertical asymptote at x equals 2.